No everyday engine build today. Once again, horsepower's taken on one of the other engines of high-performance history. This time it's a Cadillac 500, the biggest big block from GM's legendary luxury ride.
Today's other engine build begins with America's largest production block of all time.
These are going on it.
Those are nice.
Thank you.
And a little help from Maximum Torque Specialties and their engine guru, John Walker.
That will make some power.
It's a 500 cubic inch big block that powered some of our favorite luxury land yachts beginning back in 1970. GM's ever classic Cadillac. It was the first car to use designer-style bodywork. 1948 was the first year for those legendary tail fins, inspired by the twin rudders of the Lockheed P-38 Lightning, ever growing until the tail fin finale in 1959. Who knows what inspired those famous bullet bumpers? Some say it was a TV star from the 50s named Dagmar. Anyone see a resemblance? Cadillac was the first automaker to mass produce a V8 engine, and it produced 8 generations of them starting in 1914. Big block size and horsepower increased throughout the 50s and 60s. Then, for 1970, Cadillac fitted a crankshaft with a 430 stroke into a 472 engine to create a 500 cubic inch big block rated at 400 horsepower. It was the pinnacle of power for GM's luxury legend. Known for its torque, but not horsepower, at least after the first year, by the end of the production run, it was rated at only 190. But why didn't caddies power their way into the world of American hot rods?
It was never put in a performance vehicle. You know, nobody ever looked at an Eldorado or a coupe or sedan DeVille or a hearse as a performance vehicle in any way, shape, or form.
There was also the issue of available parts. That's changed with the emergence of MTS, one of the only 2 existing companies that specialize in Cadillac 500 parts and engine packages.
We found it much easier to put a lot of inventory into one engine. And now we've brought Cadillac-specific products to the market that are cut above what was available before.
We keep making parts, and every time we make new parts, we start selling them.
John brought us everything we need to build a pump gas-friendly 500, including several parts MTS designs and manufacturers. We plan to build an engine that'll have enough torque to pull a house down, and horsepower, we'll all find that out later.
The block was machined by Mike Graham in Bowling Green, Ohio. It's 90 over, has a 4.304 stroke with a 4.390 bore for 520 inches. Now it measures in at 25 3/4 inches long and weighs 595 pounds carb to pan. For reference, a small block Chevy is 21.5 inches long. If a caddy swap is on your mind, don't be afraid, they're in Fox body Mustangs. The cam is installed. Now factory cams have a fuel pump eccentric, this one does not. So MTS designed this cam button to take the place of the eccentric since we're using a hydraulic roller camshaft. It has a lobe separation angle of 110 degrees. Duration at 50 is 248 on the intake, 248 on the exhaust. Lift at the valve with a 1.7 rocker arm is 640. The upper cleveite bearings can go into place, followed by the upper half of the rear main seal that gets installed offset and a film of oil to prevent the seal from premature failure. With all the bearings lubed, this massive stock crank carefully finds its home.
There we go.
Okay, the long one goes here. Oil the studs before installing and drop on the main caps. With the caps seated, apply some Goodson Extreme Pressure Lube to the washers and studs and torque them in 3 steps, 50, 80, and finally 115 foot-pounds. It's always important to check the end play of the crankshaft.
Actually about 7 thousandths total. We're good.
All right, I'm gonna go over with this piston design with you guys today. Now it's pretty cool, the guys from MTS actually got together with the guys from Dyno to create their own profile. Now what it entails is the top ring of 1/16, second ring of 1/16, and the third ring of 3/16, along with an anti-detonation groove in between the top and second ringland. Now we went with the traditional moly coating on the skirts, but a ceramic coating on the head. Now this is a 2-valve relief piston with a positive 22 cc dish. And what that's gonna do is put us right at 10:8:1 compression for our street motor.
The rings are from Hastings and have already been file fitted. Now MTS designed the H-beam rods as well. They're 6'7", 50 long and filled with Cleveite bearings. All these parts are the reason we can double the Caddy's RPM range.
It was never, in its original form, designed to rev over 3,000 RPM. It was designed to last 500,000 miles pulling a huge car.
Oh, that's nice.
Feel good?
Yeah. We got good in play. Side clearance.
All the way back.
Shoot.
Very nice.
We're still at it, looking for the overlooked potential in this 500 Caddy,
It will make some power.
along with the pros from MTS and all the best parts possible.
Chloe supplied a true roller timing set. It's a press fit on the crank and a single row, the only one that can be used on a Cadillac. Now we can put the oil slinger on the crank snout and properly oil the timing chain and distributor gear. Before we go any further, we're going to degree the cam to assure us it's installed correctly and the cam card is accurate. The stainless timing cover can go on next and secure it with a couple of bolts to let the silicone set up. Gaskets are used on the front and back of the pan lips. Once the four corners of the block have a dab of silicone, we can install some alignment studs to hold the pan rail gaskets. Weather strip adhesive is then applied to the pan side of them, which will prevent leaks. Now we can drop on the MTS 6-quart oil pan and tighten it down in an even crisscross pattern. For a balancer, we're using an SFI rated PowerBond one-piece unit that is neutral balanced. To finish up the short block, a milling standard volume pump that was blueprinted by the guys at MTS. And next up are these aluminum cylinder heads. Now these things are spec'd out by MTS, but cast and machined at high-tech castings. Now they have 72 cc combustion chambers, and the valves measure in at 250 on the intake, 181 on the exhaust. Now check this out. Look at the size of these intake runners. They measure in at 272 cc's versus 170 in a stock head. Now they were ported by Mike Stark at CFM Performance and flow 365 CFM at 600-inch lift. The valve springs are beehives from comp cams, as well as the retainers, locks, and spring cups. Using more Goodson compression lube, we can torque the heads in 3 steps, 50, 80, and 115 foot-pounds. The lifters are hydraulic rollers made by PBM. They feature a tie bar to keep them aligned, and we'll drop them in with plenty of oil. Push rods are Comp Cam's High-Techs and are 5/16 diameter with a 9/350 length.
Now here's the rocker arm setup we got going on this big inch Caddy. Now they were made by Harlan Sharp, designed by the guys at MTS. Now it's a full roller 1/7 ratio rocker arm, 70/75 aluminum base with a hardened steel tubing for superior strength. Now these will actually fit the original cast iron cylinder heads or the aluminums made by MTS.
First thing to do is tighten the shaft bolts in small increments. We're using wipe-all towels behind the push rods to hold them in place. Now make sure the push rods are seated in the rocker cups, and this system oils the rockers through the push rods, not the shafts. We'll set the lash half turn past 0 lash. MTS's intake manifold is an aluminum piece that houses a 4150 style carburetor. The runners at the center measure in at 3.34 inches, and it's been port matched to the cylinder heads. Now this thing has an RPM range from 2200 to 8000 RPM.
And finally, with their custom valve covers, John's parts pallet is empty. Yeah, you know what's next. Everyone has a favorite engine. For the guys at MTS, it's Cadillac's 500 cubic inch big block, loaded with their parts, among others. Time to see what that passion led to.
It's a big motor. That'll make some good power.
The carb we're running on our 520 is one of Holley's new Ultra HPs in a 950 CFM. Now we ordered ours in the hardcore gray finish, and this thing is 30% lighter than earlier carbs and has a 20% larger fuel capacity in the bowls. Now they've tied in some really cool race-oriented features, like here on the throttle linkage, there's no tangs to hang up on your throttle cable. Now another thing is knurled adjustment screws for easy tool-free adjustments, and they even have Pyrex sight windows on both sides of the bowl for easy and safe float level adjustments. An MSD Pro Billet distributor and matching wires will give us spark. MTS brought their dyno headers we had recoated at nitro plate. With the EGT bungs installed, we'll be able to watch individual cylinder temps. Good fire up. Thing just sounds like a big motor. It's throaty. With the initial timing set at 31 degrees, we start off with a 25 to 5,000 RPM run, just to play it safe. Thing makes great noise. 544 horse at 5,000, 577 foot-pounds of torque at 4,600. That'll get a big old caddy moving. That's awesome.
Let's go another 500.
All right. My legs were shaking. My legs are shaking on the chair. 571, 575. This caddy is solid and ready for more. We're gonna take it to its RPM limit, 6 grand. 585, 585, I mean, on the money. Torque and horsepower, even.
Wow.
We want 33?
Yep.
591, 583.
How about one more?
Yeah, whatever you want, man.
John's target is 600.
You know what? Go 2. Go 2.
And he's going for it. Oil pressure looks good, air fuel's good, water temp. 598, 584, it's liking it. It is liking it for sure. Time to replace the brake-in oil with some Royal Purple Synthetic. And after a brief cool down, man, that thing sounds good. We'll give it one more try, just for John. Throughout the 1970s, the stock 500 made 260 horsepower. This pump gas street version already impressed us. 598, 587, dead on the money. Their full race combo topped 2,000 horsepower.
This thing's evil right out of the gate.
Big Cadillac car mover, stump puller, whatever you want to call it, that is awesome torque. Very cool.
You know who makes the best engine fasteners, but you'll be amazed at what goes into the making of supreme high-performance studs and bolts. A visit inside the home of ARP is coming right up. You're watching Horsepower. For a DVD copy of this episode, just go to PowerBlockTV.com and order your copy for just $5.95 plus shipping and handling. Start your own Horsepower collection, delivered right to your door from the Power Block.
It's a simple fact. When performance parts win at the track, they find their way to the shops of gearheads. Case in point, ARP fasteners. In the late 1960s, Gary Hotzefeld set out to make stronger, more reliable studs and bolts for race engines. Since then, Automotive Racing Products has grown from his garage to a world-famous company. Gary's son Mike's now in charge of ARP operations, where all they do is make precision, extreme strength fasteners. An intricate, painstaking process, all in-house at their California complex. Here's where it all starts, with miles of 8740 chromoly coils. After the coils are straightened, ARP's progressive forging starts with cold heading.
And it takes the raw coil and it actually does through a series of cutting, upsets, and forming. It actually makes the head onto the bolt.
For studs and larger size bolts, 12-foot bar stock is cut to lengths and sent to a hothead station like this. Today, veteran employee Danny Barrera is forming heads on Honda balancer bolts.
His electrical induction heater will heat the part to 1850 degrees in 15 seconds. I would then place it as lower die, and I will hit the press, and it would come down and form the part.
Heat treating is perhaps the most critical, precisely controlled process at ARP. Temperatures can reach 1800 degrees for quenching and tempering. Aging takes up to 16 hours, all in vertical racks that hold each piece individually for complete penetration. Shot painting removes all surface irregularities like stress risers, while improving overall exterior integrity. Quite a difference already. Next up, a facility where ARP chromoly fasteners undergo some especially critical manufacturing steps, like centerless grinding. This ensures bolts and studs are perfectly concentric.
We gave it a straight grind, an undercut grind, and now we're doing the TD grind.
Most ARP bolts are fillet rolled with a 30-degree chamfer between the head and the shank.
Filler roll dies come in and pressurize underneath the head, which strengthens it. It really squeezes the microstructure of the material and gives it a lot of fatigue strength.
Fillet rolling further compresses the grain flow. This adds more strength where it really counts. Cutting threads weakens the part. ARP rolls their threads, which also adds fatigue strength. While ARP has a dedicated quality control department overseeing accuracy of tools, procedures, and product, we discovered that workers on the floor frequently inspect and measure fasteners as part of ongoing quality control and company pride.
A lot of those guys have been with us for many years. I mean, they started out fairly young with us and stuck with us.
ARP manufactures nuts in a multi-step process that begins with blanking each hex and 12-point nut. Then sophisticated automated threading equipment taps each one with an accuracy of 1/1000th of an inch.
Tight, right?
Pete is a veteran machinist who not only helped refine the nut-making process, he also mentors younger, newer employees.
I'm happy to work with this kid. I'm happy I'm able to show what I know.
In surface prep, steel parts like these nuts are placed in tumblers full of one of 5 different media, from various ceramic particles down to walnut shells and corn husk. The results? A micro-polished, flawless finish. Most studs and many bolts go through a multi-stage finishing process and application of a black oxide permanent finish. So are they totally finished?
At the end of the day, all the rolling and filler rolling and grinding and forging just goes right to that room, and that's where it's all put to the test.
In fact, random samples from every production run go through destructive testing. They fatigue test fasteners to elevated loads that are 10% above aerospace requirements, usually to 1 million cycles. Tensile testing is simply pulling on a fastener until it breaks. That's an OEM stud on the left. The ARP has a tensile strength of over 190,000 PSI, so it'll be a while before it lets go. Finally, this is where more than 1,000 different engine kits are shipped to race teams and builders around the world.
It wasn't always that way. Those are all hard fought for customers.
So building a better bolt, if you will, is an enormous endeavor. That's what it takes to keep the most powerful engines together and winning.
When you find work that you enjoy doing it, you do it as best you can. We've always liked being better than the other guys.